Hi everyone. Again, we are going to be looking at another topic, which is ratio and proportion. And we have a slide here. We're going to be going through this slide, and we are going to be explaining to ourselves ratios and proportion and examples under them. So, what is ratio? Proportion. A proportion is a mathematical comparison between two numbers. Comparison of number whether the same, whether it is less than or is greater than each other. So when you're talking about proportion, you are just trying to compare two numbers to know if they are the same, they are less, and if they are greater than each other. And we have types of proportion. We're going to be looking at two types of proportion here. The first one is direct proportion, and we have indirect proportion. For direct proportions, it shows relationship between two quantities, and it's always we have a constant value, which is k, that we use to denote proportionality. And the symbol for proportion is this. This is the proportionality sign for proportion. So we are we have two type of proportion, which is direct proportion and indirect proportion. So now let's look at these activities, and let's see. The symbol of a proportion is represented by what? This is the sign for the proportionality. So we have this as the symbol. What are the two type of proportion that we have? As we have mentioned, is we have direct proportion and indirect proportion. That is indirect proportion. We can also call it inverse proportion. So those are the two type of proportion that we have. Now we're going to be looking at direct proportion. Well, for direct proportion, two values are said to be direct when one quantity increases or decreases in the same proportion with the other quantity. So if you have two numbers and they are increasing and decreasing at the same proportion, then we call that type of proportion a direct proportion. And for direct proportion, we have two methods. We can use two methods to solve direct proportion, which is ratio method or unitary method. So we are going to be using the two methods, and we are going to be solving examples. Now for ratio method, we have this here. Tin and copper are mixed in this ratio, that is 8:3. How much is tin? How much tin is needed to mix with 36 gram of copper? So how much tin is needed to have 36 gram of copper? Now for that, for us to have we don't know the numbers of the gram, so we have to express it in the ratio of each other. So we don't know the numbers of a gram of tin, so we denote that as what? As x. So we say that let x be the numbers of mass of tin, while we have 36 copper. So we are going to be expressing in this ratio 8/3. So since we don't have the number of tin and tin comes from, so we are going to be having x divided by 36 equals to 8 divided by 3. So we have x divided by 3 over 8 divided by 3. So we are going to be solving that to get. So let's solve. We have x over 36 equals 8/3. So by the time we cross multiply, x will multiply 3, 36 also will multiply 8. So we can have it to be 3x equals to 36 times 8. We want to get the number of x, so we divide this one by 3, we divide it as well by 3. So we are dividing both sides by 3 so that s will be the only one standing here. So this 3, we cancel 3, and we have x here. So 36 times 8, what is that? 36 times 8 will give us 288, and we divide by 3. So by the time we divide 288 by 3, our answer is going to be 96. So we are going to be having 96 grams of tin. We are going to be having 96 grams of tin. So that's going to be the grams of tin that we need. Let's use the same method for to solve the unitary method. Now for the unitary method, when you're talking about unit means one. So we just needed to calculate based on each unit. So we need to know each unit. If we get to know each unit, then we'll be able to know the total number of quantity of whatever we are being given. So let's look at this question here. We have the tin and copper are mixed in the ratio ratio 3. How much is tin needed when we have 36 gram of copper? So we are using unitary method. If we have 36 gram of copper, then one copper will give us what? That one copper is going to give us 36 one copper is going to give us what? 8/3 gram of a tin. So if one copper is giving us 8/3 gram of tin, now 36 copper is going to give us what? It's going to give us 36 multiplied by 8/3 gram of tin. So that's what we are going to be solving together. Now let's solve together and we feel the correct numbers to the boxes after we are done solving. So let's solve together. So let's solve it and let's see what we have. So, okay, now we have here we have 1 gram to be what? 8/3 gram of tin. That's going to be one gram of copper. So 36 gram of copper is going to give us what? 36 multiplied by 8/3 gram of tin. So that's what it's going to give us. So if you have that, it's going to be what? 36 multiplied by 8/3. We have our gram. Remember, we are calculating numbers of things that is going to be mixed with the copper. So we are going to have that as well, 288 divided by 3. So if you have 288 divided by 3, we have 96 grams. So we are going to be having 96 grams of tin mixed up with 36 grams of copper to give us the ratio of 8/3. So we are going to be dragging in the right answers to the boxes. So for this one is going to be what? 8/3 based on the calculation we have. Now for us to get 36 grams of copper, we have to have 36 multiplied by what? 8/3 grams of copper. So if we have that, we have 36 times 8 then divided by 3 grams to give us what? The grams of tin. So by the time we multiply, that is 288 divided by 3, which will give us 96 gram of tin. So let's check. Yeah, that is the right answer for that expression. So that gives us there was another edge to this. Let's look at this. This is another subtopic, which is inverse proportion. I've told us before that inverse proportion also is known as what? Indirect proportion. So inverse proportion, two quantities are said to be inverse proportional when an increase in one quantity cause a decrease in the other quantity and vice versa. So if you have two quantity, as one increases, the other decreases, and vice versa. As the other decreases, the first one increases. So now let's look at the work example here. We are going to just be playing around this because it's already a work example. So if 8 people pick the apple from a tree in 6 days, how many days will it take 3 people? So for 8 people to pick apples from a tree in 6 days, so for a person it's going to be what? It's going to be 8 times 6. So for a person to actually pick that amount of apple is going to be what? 8 times 6. So we are going to be having, for one person is going to be 8 multiplied by 6. That's the number of days a person is going to pick that apple. That is 42 days. So for one person it's going to take 42 days to pick that amount of apple from the tree. Now for 3 days, 3 people, it's going to take how many days? It's going to take 86. It's going to take 8 multiplied by 6 rather divided by 3, because for a person is taking 42 days. So for 3 persons it's going to be taking 42 divided by 3. So 42 divided by 3 is going to give us what? 16. So for 3 people is going to be taking 16 days to pick that apple. So let's check. That is the answer, 16 days for that apple to be picked from the tree. Now we have another work example here, which is when you are trying to divide quantity in a given ratio. We have a specific set of ratio and we have to divide a quantity based on the ratio. So let's look at this. A factory produce car in red, blue, white, green in this ratio. So for red we have 7, For blue, we have 5. For white, we have 3 ratio. And for green, we have 1 ratio. And the productions of that car is what? 48,000. So how many are white? We want to know the numbers of white. We want to know the numbers of red. And want to know the numbers of green. So for us to know the number of white, red, and green, what we need to do is we add up all the ratio. That is 7 plus 5 plus 3 plus 1, and the total answer should be 16. So by the time you have 16, then we are now to divide. We divide we are looking for white now. So we pick what is the ratio of white here. The ratio of white is what? Is 3. So you pick 3, then you divide 3 by 16, then multiply by 48,000. Then we get the number of white cars. Now for red cars, what we need to do is what? We pick the ratio of red. The ratio of red is what? Is 7. Then divide it by 16, then multiply by 48,000. We have the numbers of red cars. For green cars as well, we pick the ratio of green cars. The ratio of green cars here is what? Is 1. Then you multiply it by 48,000 and divide by 16. So if you divide that by 16, then we have the numbers of green cars. So quickly we are going to be solving that together. So by the time we solve that, we're going to have the numbers of cars for each colors. So let's solve that. So we have 3 multiplied by 4,800 divided by 16. That will give us 9,000. So the number of white car is 9,000. The next one is red car. That is 7 multiplied divided by 16 multiplied by 4,800. That will give us 21,000. So we have 21,000 red cars. Now for green cars, it's going to be 1 over 16 multiplied by 48,000. So that is 48,000 divided by 16, which is 3,000. And that's the numbers of green cars that we have. Let's pick the right answer to each process. By the time you add 7 plus 5 plus 3 plus 1, you have 16. And by the time we have this expression, for the number of red cars, we have 21,000. And numbers of green cars, we have 3,000. So we have 3,000 for green cars. So let's check. So now that leads us to the next topic, which is compound measure. So under this, we want to look at what we can actually, the ratios we can use, and the proportions also that we can use under measures. Something like we have, sometimes you can consider some common measures, like we have speed, we have density, then we have population density as well. So for speed is calculated as distance over time. Then we can have the unit to be meter per second or kilometer per second. Now for distance, it is calculated as what? Speed multiplied by time. So, and for time, we can calculate it as distance divided by speed. So those are the measures, common measures that we can use for ratios and proportion. Now we can also look at density. As I said it's a measure of the masses of a substance per unit of its volume, and is calculated using this formula. So for density, we have masses over volume. Then we can calculate population density as well. We want to know the total number of people living in the set of community at a particular time. So for us to calculate that, it's going to be the number of people divided by the land area. So we have to calculate the land area, then we divide through by the total number of people. So we have an example here. This example here is telling us that we should calculate the speed average for a distance traveled by a train for 140 kilometer in 1 hour, in 1 hour and a half. So we're quickly going to be calculating that. Now we have this to be, since we said average speed is what? Total distance over total time. So we have 140 divided by 1 and a half. Now we change this to, this is a mixed fraction. We change it to an improper fraction. So we have 140 divided by 3 over 2. By the time you change that, it's going to be 140 multiplied by 2 divided by 3, which is 280 divided by 3. How many times can 3 goes in 280? It's going to give us 93 33 whole number 1 over 3. So that is the speed measured in kilometers. So with this, we're going to be picking the answers for this question here is what? 93 whole number 1 over 3 kilometers. So this take us to the end of this topic. We want you to subscribe to our channels, www.edubbey.com, for the full interactive content of this topic. Thanks for listening.